here. We'll start going over these. So we're given IR, proton, and carbon NMR. We have a molecular formula of C6H14O2, and that has how many degrees of unsaturation? Everyone agrees it's 0. So we're always using this. We're always using the general molecular formula for an alkane. And again, really what I need to impress upon you the most is, even though that's like a simple word, you have to like understand how to deploy that knowledge. You can learn as much crap as you want in the next 4 years while you're here at USM. If you don't know how to apply that stuff you learned, like what good is it? So alkane means every carbon's sp3 hybridized. So that's what we're going to use. That means every carbon has the maximum number of hydrogens it can get. So we have n is equal to 6. So we have 2n, that's 12, plus 2, that's 14. That's what it should be. This is what we are given. The oxygen count does nothing to the hydrogen count. So we're at our revised formula is C6H14, and we know that's what it should be, so that's 0. What do halogens do to the hydrogen count? Halogens add. What does nitrogen do? Subtracts. So if you're from the Upper Peninsula of Michigan, you would say nitrogen. So do you say butter or butter? Butter or butter? You have like a T or a hard D. So, yes. Say it again. No. You can guarantee yourself there are 3 questions where you have to figure out what the formula is. So think about when we were going through all these problems and we eventually were arriving at the formula. So of the 6 questions, one of them, what is the formula? Another one, what is the structure? So then of the remaining 4, it's questions about specific pieces of data.
And we'll have mass spec, right?
Yes. So 0 degrees of unsaturation. What's in the IR? So there's CH, that's like, yeah, big deal, everything has CH. So what else is in there? So we have an OH. So that's helpful, but maybe not a whole lot of helpful because there's actually 2 oxygens. So that oxygen we need to come up with another functional group that has oxygen. But you can't say carbonyl, because why? Well, if you look at the IR, there's no carbonyl stretch. But the other thing we already said, there's no degrees of unsaturation. So really, this is why you want to write stuff down, because your brain will trick you, and that's one of the tricks it will play on you. So no degrees of unsaturation, no carbonyls. So let's go ahead and look at the numbers in blue in the proton are presumably the hydrogen count or the integration or ratios. Maybe what we'll do, let's count the unique numbers in blue. Not the sum, but just how many numbers in blue are there. So that's telling us there's 7 unique type of H. And the actual numbers themselves are the integrations. 2, 2, 2, 1, 2, 2, 3. What is that total? So that total is 14, right? That's what we have in the molecular formula, so they're all accounted for. The carbon has, the molecular formula says there's 6 carbons. How many carbons do you count in the carbon NMR? So there's 6 unique type of carbon, meaning there's no symmetry. So we could just start drawing stuff because there's no unsaturation. Remember that worksheet you guys did where you give in a molecular formula and you start drawing things and naming it and that sort of thing? But maybe let's try to be a little bit more formal about this. So let's read the proton NMR, and you have a peak at about 0.9. That is, what multiplicity is that? It's a triplet. So hopefully you'll agree with what I'm about to do. So it integrates to 3, so it's a CH3 group. So it's a triplet, so we can say one fragment in there is this. So I put the CH2 group in there because I know the thing that integrates to 3 is a triplet, so it has 2 neighbors. So we're good with that. But we have not yet assigned what the CH2 is, which one it is. If we go over 1.4 and say 1.6, those are both 2, so I could say those are CH2s. Are they bonded together? I don't know. So let's not jump to conclusions yet. See this thing that equals 1? That might be a bit of a sticky wicket, because that could either be an OH or a CH. Then we have a couple of, I would assume, are basically CH2 groups, right? And I'm making that assumption based on the fact they integrate to 2. We're just going to call them CH2s. So we already said we definitely know that's in there, those 2 things. Maybe I'll give you guys a minute or 2. I think on the exam you have 2.34 minutes per question. So maybe take 2.34 minutes, plunk all those fragments together and see if you get a structure that makes sense. Yes. If it was like 25 of these spectrums, then it would be tough.
So what would be like a question
So, I mean, if you look at this spectrum, sort of like I did today in class, what functional group is obvious from this IR spectrum? Then consider what the choices could be. Carboxylic acid, amide, alcohol, alkene. So you're sort of using a flow chart of logic to arrive at the right answer.
So what's that?
Say what?
What? It's just the alcohol with some extra CH stretching.
Yeah, this stuff here, that's always CH stretching. It's in every molecule. You can't get away from it.
So you just kind of ignore it.
Yeah, I mean, it's not helpful in my opinion. This other thing, that's the OH. That's what's differentiated. So maybe what can help you in your proposal here is see this gap between, say, 35 and 60. I would argue to you that everything after 60, those carbons have to be bonded to an oxygen. That's what differentiates them from the other three. So the other three are carbons bonded to carbon. So considering you've used one of the oxygens for an alcohol, what functional group does oxygen number 2 have to be part of? An ether. So that word should translate onto your sheet. You need like an ether fragment. So what is that? Where those squiggly lines are both carbon. So now you need to put all these things together so that you get like the right integrations and the right chemical shifts. I would argue again that these, I would call those multiplets, so that means the neighbors are like 4 or more. That's why they look so crappy. Anyone want to come draw a proposal? Behold the blue marker of power. Hopefully there's enough juice left in that one. Is the ACS doing anything after this tonight?
Not tonight.
Not tonight.
I don't, we might not get to do them for this.
Oh, it's heartbreaking. Not quite.
Actually, I have another one using my book bag from drawing, so I'm gonna give that back to you. Another one of
The
those.
green one?
Yeah, I have the green one.
So what's wrong with this claim? There's a ring. So you're sort of like a lawyer in training here. You're learning to refute claims. So when I worked at Johnson & Johnson, I got my name on like 4 patents because I think they were feeling generous. Throw this dude on there. What a patent is a claim. And you have to give evidence that the claim is true. So one set of lawyers is writing the English words for this claim, and every other company on earth is trying to break that claim by proving it's false. So when you're writing a claim, you want to be as bulletproof as you can. So you want to consider all the evidence that's possible. And if you have, like, I would say this is sort of a logical inconsistency, because we already said there's 0 degrees of unsaturation. So therefore you can't, it should sort of self-eliminate.
Does that mean that someone can take away your patent?
Yes. That's a big business, especially in like West Texas. There's judiciary there that love to break patents and make people rich. So maybe I'll throw up a claim and see what you guys think, whether it's bunk or not. I think I have all the carbons, the hydrogens, the oxygens. Anyone else get that? Exactly what you drew. Fantastic. Pat yourself on the back, but don't break your arm doing it. That's what they say. Uh-oh, someone's throwing shade. Shouldn't there be a CH? So your question is about this one right here, right? So we were saying it's either that or that. Well, that is every sort of CH that's in there. You know what I'm saying? So that's why it's really not helpful to use that piece of information. Yeah, I apologize if that sort of threw you guys off. Uh-oh. We have another claim.
The red marker of destiny.
Yes. Behold, a great red marker. I think I heard it in the chatter. How are you going to break this claim? So CH3, CH3. So the other thing you can use is, what multiplicity should that be? A singlet that integrates to 3, that would be around like this region. So that's something you could say to refute that proposal. if this oxygen was at the terminal,
Like unless you just drew it, the oxygen was on the very
yeah, at that point it would have that H, and I think you could deny that claim, pretend you're my health insurance, will deny that claim, because it has two H's at that point, two OHs.
Are those blue numbers, are those gonna be on the test?
They are not. Again, the scenarios aren't too bad. If you're given the numbers, you're gonna get like 1 or 1.5, then you multiply by 2. You've seen it enough. Again, don't fear the beast in the jungle, the unknown thing. Don't create unknown scenarios of, it's really going to be something you've seen before. Whether you have the neural pathway is strong or not is how many of these you've done. So it's this right up here.
Where are you from?
Let me use, here's the laser.
Yeah, but I meant like the drawing of the structure.
The drawing of the structure?
Okay. Sorry I asked. I'm sorry.
You want it drawn on the board?
Yeah.
Okay.
I'm trying to understand.
So we have how many? 1, 2, 3 CH2s. So the giveaway for this is you have that cluster of CH2s that are separate from the other ones. That CH2 bonded to oxygen, this CH2 bonded to oxygen, that CH2 bonded to oxygen. So that's mirrored in the carbon as well, above 60. Then you have this cluster of just regular sp3s, 40 and below. Move on to another one here from the book. I'm debating whether I want to do a problem that has 4 oxygens in it. Maybe let's come back to that one. Another 4 oxygen. These other ones if you want, or we can answer some different types of questions. Up to you. We have 20 minutes left. You want to do this one? So I'm not going to lie, 4 oxygen sort of scares me. But I think we'll figure it out. How many degrees of unsaturation? We have C8H14O4. So 2 sounds good. What does the peak at 1736 tell you? So a carbonyl is how many degrees of unsaturation? It's 1. So either the molecule has like 2 carbonyls and it's symmetric, or there's a carbonyl like embedded in a ring or something. So if we look at the proton, we have 3 unique type of peak. The other thing, so this region here, obviously there's no NH because there's no nitrogen in the molecular formula, but there's no OH either, so you would see that. So that, again, that's limiting. If you think about what are the carbonyl containing functional groups, let's just list them off right now. That's absolutely not true. The benzene ring has to be between, say, 6 to 8 ppm. So I can tell you it's not an aldehyde because an IR aldehyde has a signature that goes along with the carbonyl that stands out. So you might want to review that, what that is. So we're either dealing with a ketone or an ester. We're not dealing with an acid. We're not dealing with an anhydride. We're not dealing with an amide because the molecular formula would have nitrogen. It's also not an acid chloride or a halide because there's no halogens. When I look at the proton, I can tell you right away that the quartet and the triplet are coupled. So it has to have this fragment, CH2, CH3. And then something blocking it. I would say the thing blocking it is probably oxygen, because that leads to that isolated spin system. If you look at the proton decoupled carbon NMR, how many unique type of carbon do you see? So you see 4. We've already assigned this one. That belongs to the carbonyl. The depth spectrum, again, we said CH3 is phased up. That's a CH3. CH2 is phased down. We have 2 CH2s. So thus far we've accounted for 3 unique type of carbon, 2 unique type of carbon, and 1 of the type of oxygen. So it appears to me that this is CH3, CH2, and then this thing in the middle here, this singlet, is CH2. So how do I know that? Because the other carbons were phase negative. So that's how I can tell that that's 2. If we add that together, 3 plus 2 plus 2, that's 7. So half of 14 is 7. So the molecule is symmetric somehow. So we got to figure out how. I think I know, but this isn't about me, it's about you. Yes.
On the carbon NMR, I see the depth 135. What about the depth 90? Will that always not be shown? Or?
The depth 90 wouldn't help you here because there's no CH to differentiate.
Well, that's on the
Yeah. So you're going to be given depth 135. CH, CH3 are phased up, CH2 is phased down.
So can we automatically assume if there's no depth 90, there is no CH?
No. But the way you figure it out, again, you go back to the proton data and see if there's like a single peak that integrates to 1. And that will help you differentiate between CH3 and CH. Again, figuring this stuff out is really sort of a test of logical thinking. So think about, I think I showed you guys, like the Cold Spring Harbor or Scripps Institute. When these scientists go scuba diving and they harvest these sponges from the bottom of the ocean, and they take that sponge back and they freeze dry it, that just means they're getting rid of the water. They soak it in methanol, and then they're extracting out the metabolites that microorganisms produce. At that point, they have zero idea what the structure of those compounds is, and they're incredibly complex. If you're interested, I'll forward you an article about one the synthetic chemist at Harvard made that has like, I want to say it took them like 124 linear chemical steps to make this compound from scratch. So when you run a reaction in lab, think about the yield you get. And so basically you need 100% yield each time to end up with anything at the end. And so this compound is actually, it's in the clinic for treating, I think, some sort of cancer. Do we have any proposals? Keeping in mind that the molecule is symmetric. Yeah,
I have a question about that.
sure,
Can you get just the formula from looking at the mass spec?
you can.
Can you do a problem and get the formula from just looking at the mass spec?
Sure. Let me see if the book has one. If not, we'll go back to the other ones that were already up there. Anyone have an idea what this is? All right, I'll show you my proposal, whether you agree or not. So that's what I came up with. So it's basically a diester. So in 256, you'll learn a mnemonic, oh my, such good apple pie. So this is diethyl succinate. So if you split the molecule in half, you split it in half, those two mirror each other, so that's what gives you that singlet. You multiply everything by 2, that's how you get the 4 in the middle. So you have the 10 plus the 4, that gives you your 14. So we'll finish up on this mass spec. All right, let's do this. This seems a little bit more manageable. So what is this one? Maybe is a bit too straightforward. So conceptual checkpoint. Do you have four IR? Huh?
What's the structure of the last one?
What? The ones I skipped?
Not like the one that.
So we'll do this one real quick. It says, of the following IR, which is an alcohol, carboxylic acid, or neither? So let me put some things in here so we can communicate a little bit better. If I call this A, B, C, D. So which one's an alcohol? Which one's an acid? So in my opinion, B and D are obviously neither of those. And what functional groups could they be? I do not know. Again, IR is something that it's either really standing out to you or it's like not there. So you don't want to read too much into it.
So like in the IR, like for the test, which ones do we need to focus on? Like alcohol, carboxylic acid, like they aren't really different.
So maybe let me,
So that acid is acid because it has a pretty, I can't read the numbers at the bottom, but below 2,000.
so let's do two things here. That's the alcohol peak. See how it comes up and then this back down? If I were to draw a line here, I would call that the baseline of the IR. IR spectra starts off at 100% transmittance. That means the laser is going completely through the sample. When it dips down and you see the peak, that's when the laser is interacting with the bond dipole. And what you're seeing is the laser excite that bond dipole, like a spring, sort of. That's how you see this. It comes down off the baseline, and you see the peak. The reason it goes back up is because the laser intensity is past the energy of exciting that dipole. So this region here, I say, is baseline separated. In the acid, it comes down, that's the OH of the acid. Now instead of going back up, it's not baseline separated. The OH is merged now with this CH stuff here. That's the other thing. And the fact that you have a carbonyl. So an acid has those two signatures. So how do you know if something's an ester? So if you had to differentiate between an alcohol, an acid, and an ester, what are some things you would look for? Yeah.
Doesn't an ester have 2 peaks in the carbonyl, kind of like, or no?
What functional group has 2 peaks in the carbonyl region? What? Did you say anhydride? I'm pretty sure you said anhydride. So that's an anhydride. So an anhydride has two carbonyls, so therefore you see two stretches. And what that looks like in the carbonyl region is something like that. So it is sort of tricky that you can't just use IR to determine an ester. You'd have a carbonyl. You disagree? You're going to have a carbonyl, but you're not going to have an OH stretch. So how do you know? You have to use the mass spec to determine that there's a second oxygen. And again, that's one of those things where you have to be sort of like Muhammad Ali. You gotta be fluid in how you move. Don't get knocked out by ignoring a piece of data or evidence. Because if you completely ignore something, it's going to cloud your judgment in what you propose. So let me ask you a question where we had a question not related to this, but there's three main regions in the IR. We've talked about region 1 and region 3 a lot. What's region 2 contain? sp hybridized carbon. What functional groups have sp hybridized carbon? Alkyne and nitriles. Let's leave it at that. Okay, so let's, this goes back to the question I think we first started with mass spec. Match each compound with the appropriate spectrum. So you're given a couple benzene derivatives, A, B, C, D. So let's make assignments first. Looking at the spectra, is there one you can pick out and then make an assignment to a structure? The second one is what? So chlorobenzene. And why is that? So your parent is 3-to-1 ratio. Again, it's a visual thing. So I think I've said this before. I don't know if you believe it or not. I assume everyone in here drives. At some point you learn how to drive. And at some point in human civilization, a group of people got together and said, an 8-sided shape that is colored red is going to mean stop. If it was a circle colored purple and we all agreed that meant stop, we would then stop. So it's just like that's what this is. It's don't overcomplicate it because the concept resides in organic chemistry. You all know how to learn. I mean, you learn how to do many other things. Just don't make this any harder than it has to be. So we have this one's out of the way. What's another one that stands out? So we have a 1-to-1 ratio here, and that's the bromo benzene. Now the last two, again, this is a smidge more subtle, I would say. So why do you say that?
Because there seems to be 2 peaks and in H2 we have 3.
I was saying D would be a lean because it has an R in
You mean C?
it. Does that say 9?
Yeah, it's tough to read.
And then the top one says what?
110.
It looks like 94 to me. This little blip right there is 95. No, so that's the main peak's 94.
See, I'm looking at the far right, C would have to be a triplet.
I wouldn't.
Unless I'm
I wouldn't read too much into like sort of multiplicity in mass spec like that. But I think you were right when you said about the odd mass. If I look, maybe you want to bust out your calculator. 14 plus 2 is 16. So 16 plus 1 is 17. So you are right in the sense that if there's one nitrogen, the mass has to be odd. But what is C6H5 worth? So to me, it looks like, because I'm closer to this, if I count, this looks like it's more like 93, because there's 90, then there's 1, 2, that's 93. And then the 77 plus 17, that should be this one here up. So that would be the phenol. And then this. Where you have to get out your monocle, and I think everything's readable that needs to be readable. Again, most of the data should reinforce itself if there is the presence of nitrogen or not. I would say, so from those handouts, the spectra that are going to be on there from that book that resemble those handouts, you have plenty of space on those sheets to write your thoughts down. And you want to write your thoughts down because, again, the 6 questions are tied to that specific spectrum. So maybe you want to go through it first, pick some things out, look at the questions, then start answering them. So again, there's going to be 4 questions about like the data itself, a question about the molecular formula, and a question about the structure. I can go back to these other about if you were given D, if you were given that mass spectrum, could you figure out what the molecular formula was without knowing the structure? And I would argue that you could. You're going to make the assumption that everything has carbon, everything has hydrogen. If you're looking at D, you should know, okay, that has bromine in it. You may or may not be able to see it, but the mass, one of the masses there is 156. So that's the parent. So again, you don't know the structure, you're trying to determine the molecular formula, you subtract out 79. So 156 minus 79. Is 77. So now you're going to assume that everything in that 77 is carbon and hydrogen. So 77 divided by 12 is what? So I would say in general you have to use the lower number. So if it's 6 times 12 is what, 72? So that's pretty much what you're doing. So what if the mass spec doesn't have halogen? How do you know if there's another heteroatom? You look at the IR. If the IR shows a carbonyl, you know that there's an oxygen. You can subtract out the oxygen. If it shows an acid, that means you know you have 2 oxygens, so you'd subtract out 32. If the mass is odd, you have an odd number of nitrogens. So if the mass is odd, you have an odd number of nitrogens. Just repeat that. You'll hear it in your sleep tonight. Then tomorrow you'll be like, that makes sense. So I guess we'll wrap up. If you have things that you're not sure about, send me an email. I'll try to respond within a couple hours of receiving said email. If you're really unsure, we can try to meet tomorrow. Yeah.